Welcome to the Topic Blast Revision Series Day 4 walkthrough. Today's topic is statistical diagrams, so have your booklet ready and we can start going through the answers. So staying with statistics like we did yesterday, we're looking today at statistical diagrams. So in this question we're given a table like we saw yesterday, our group frequency table, and this time we're asked to draw a cumulative frequency graph. Now we have to be careful because with this table you could be asked to draw a number of different graphs, so it's making sure that you read through this and you're really clear what graph are they asking you to draw. So for a cumulative frequency graph, we're going to work out our cumulative frequency. Now what our cumulative frequency means is it means that we're finding a running total. So we're going to add up our frequencies as we go along. So our running total then is 4, 24, 42 and 48. Now often they'll put that number in the first line somewhere so you can compare those two numbers. We don't have that luxury in this question, but it's worth checking if that number is written there that those two numbers match. Don't worry that it doesn't match the 50 up here either. It often doesn't, and the point is that we don't worry about the top of the axes. This is where our graph is going to finish at 48. Now our cumulative frequency is obviously on our y-axis. For our x-axis, or for our bottom axis, we're going to use these upper values. So we're going to plot these points. So for the first one, we're going to go to 140 and we're going to plot it at 4. Now if we look here, from there to there, that's a gap of 10. There's 10 boxes, so then each box is worth 1. And it's worth checking that because sometimes they use 2, sometimes they use 4, sometimes they use 5. So it's worth checking what each of those boxes are. Sometimes even the little box is 0.5. So we now know that each of those boxes is worth 1. So therefore 140 and 4 is just there. So we mark that. The next one, we go to 160 and up to 24. So 24 is there. Next one, 180 up to 42 on our cumulative frequency. So there's our 42. And then finally 200 up to 48. Again, don't worry it doesn't go to the box at the top of your axis. It will on occasions, it won't on occasions, but it's making sure that you're accurately plotting those points. Now the tolerance you're allowed for any of these is plus or minus half a box. That's what you're allowed to draw. So if you're half a box too high or half a box too low, that's fine, but anything outside of that, they will mark it wrong. Now to figure out where our graph starts on our bottom axis, we're always going to look at this first number here, this 120. So we're going to go down to our 120. That's where our graph is going to start. Now what we're going to do is we're going to join these dots using a smooth freehand curve. Okay, so we're going to draw this nice and carefully. Take your time with this. You can go dot to dot and then lift your pen. Dot to dot, lift your pen. Dot to dot, lift your pen. Dot to dot and lift your pen. Now what they actually look for is to make sure that you go through each of your points within half a small box like we said earlier on. Okay, that's for your points and your line, and that your graph is always increasing. So you don't want your graph to drop in the middle or anything like that. The other thing they don't want to see is feathering, so they don't want to see you drawing like that. Okay, so you need to be really clear on that. Okay, now we're asked to find the median. Now the median, remember, is halfway or the middle value. So there's 48 people in total. Half of that is 24. So we're looking for the 24th person. So on our cumulative frequency column, we go up to 24, which is here. And then you'll use a ruler in your exam, but we're going to come all the way across to our line. Okay, you can use a ruler to make this a little bit quicker for yourself. And luckily for us, that actually lands exactly onto one of the points we had before. So we know it'll come perfectly down to that line, which is 160. So the median in this question is 160. So this one we have a second cumulative frequency question. So we're going to start again by working out our cumulative frequency. So that gives us 5. 5 plus 14 is 19, plus 11 is 30, plus 6 is 36. Now you'll notice this time on our vertical axes, we've not got our label, nor have we got it, any values. So we're going to look at our numbers here. It goes up to 36. So let's see. If we try 10, 20, 30, 40, 50, okay, that works because we can fit our 36 in and every box is worth 1. Remember, this top number doesn't have to match the end of your cumulative frequency. You can keep it whatever way you want it to be. But if we end up with this 36 being, for example, 80 or 90 or 100, we then have to think about a different scale to make it work for us. So again, we're going to plot our upper bounds with that cumulative frequency we just worked out. So we've got 110 up to 5. We've got 120 up to 19. We've got 140 up to 30. And we've got 160 up to 36. Again, don't worry that we haven't gone all the way to the end with 180. We just do whatever we need here on this axis. Okay, again, trying to find our first value. We've got 100 here, so we join it back to this one. And then using a smooth curve, remember what I said, if we draw dot to dot, it makes it a little bit easier, and then lift your pen after each one. Okay, and that's our axis. As long as it is within half a box of tolerance and doesn't come back down, that's normally right. Now you'll find it a little bit easier. If you struggle with these curves and you think I just can't get this right, just use a ruler. You can use a ruler to draw straight lines between each of them, and that'll usually get you the marks anyway. Now the second part of the question asks you to find the interquartile range. So for the interquartile range, that's the upper quartile minus the lower quartile. So range we've seen before. We need to find the upper quartile and the lower quartile. Now quartile sounds like quarter. So if we have a think, the median here, the median value, well, we have 36 values. So 36 divided by 2 is the 18th value. Okay, so that's 18. So therefore, the lower quartile is going to be half of that. 18 divided by 2, which is 9. And the upper quartile is just going to be the median plus the lower quartile, which is 27. So we're looking for the 27th value and the 9th value. So again, on our graph, if we go on our 9th value and then come down. Now again, trying to read this scale, this whole gap here is 20, but there's only 10 boxes. So each box is worth 2. So we can then say, well, that must be 120, 118, 116. So that value there, the lower quartile, is 116. Now you can obviously use a ruler for that to make sure it's perfectly accurate. And it's correct from your graph. So my graph says 116. Depending on how you've drawn it, you might have got 118, you might have got 114. There will be that level of variability they'll allow. The upper quartile then is the 27th value. So we go to the 27th value, we come across to our graph, and we come down. And again, following this, using a ruler, because it'll make it easier for us, that's 130, 132, 134. So that's 134. So the upper quartile is 134. Therefore, finally, running short on space, so I'll do it up here at the top. The interquartile range is 134 minus 116, which gives us an answer of 18. Okay, so our answer for the interquartile range is 18. So this question looks similar to our previous question. We've got a grid to draw our graph on, and we've got a similar looking table to the one before. However, in this case, we're asked to draw a histogram. Now a histogram looks a bit like a bar chart, but the bars are going to be different widths. And because of that, our heights are going to be calculated using our frequency density. Now, our frequency density is calculated by doing frequency divided by our class width. Now, what's our class width? Well, our class width, these of them, no matter what it says, whether it says marks, whether it says height, whether it says mass, they're called our classes because it's where our intervals are. Our class width is just the difference between the smallest value and the highest value. So in this case, our class width is 20, the second one is 10, the third one is 10, the fourth one is 10, and finally the last one is 30. So then we're going to calculate our frequency density. We can just use FD for that. So our frequency density is our frequency divided by our class width, which is 0.6, 3.1, 5.6, 4.2, and 15 divided by 30, which is 0.5. Now, our frequency density is our height, and then the width of our bar is going to be based on each of our intervals. So if we look at our scale here, let's try like we did in the last one. What if we went 1, so every little box is worth 0.1, 2, 3, 4, 5. That goes up to 5.5. Now that's not going to work for us because we need it to go as high as 5.6. So we're going to need to find something else to use for our scale. So what we can use for our scale instead is we'll just have to use a smaller one. So let's put 1, 2, 3, 4, 5, 6. We don't have to use the entire graph. We can ignore all that top bit, but this now works as a nice scale. Now we've got a gap of 1. if we look here, just again figuring out scale, we've got a gap of 1, and then there's 5 boxes, so every box is worth 0.2 for us. So with that in mind, let's draw our histogram. So we've got a height of 0.6, and it happens between 0 and 20. So 0.6 will come across here, we'll go to our 20, and there's our first bar. Now you'll use a ruler, it'll be much neater. I'm doing these freehand. The next one between 20 and 30 goes up to 3.1, so that goes to there for us. Again, between 20 and 30, so we come across to here, and then we come down. The next one between 30 and 40 goes to 5.6, and again that 5.6 is the reason we couldn't use the scale of every box is worth 0.1, because that would have been too big for the grid we have. Now often it will work on the grid, but what we're going to want to do is make sure that it fits. The next one between 40 and 50 goes to 4.2. So again, 4.2, remember in each box is worth 0.2, so that's only one box higher than 4. And then finally, we're going between 50 and 80, so that's up 0.5. So that's actually going to be 2.5 boxes. So be conscious that it's not always going to be exactly one box. It might be 2.5 boxes, etc. Again, using a ruler, yours will be much more accurate than mine. But that will be your histogram. Now some people like to shade them in, you don't need to, that would be sufficient. Just make sure that you're using a pencil that's clear enough to see it on your grid. Now similarly in this one, it says here's some information about the distance in meters a javelin is thrown. Okay, so again, we're asked to draw a histogram. So because we're asked to draw a histogram, we're going to find our class width first. So our class width here is 20, 5, 5, and 10. And then our frequency density, if we work those out, that's 0.75. That's going to give us 4.6. That's going to give us 3.4. And then finally, that's going to give us 0.3. Now we've got neither scale on this, so let's check and see what works here. We could go 50, 60, 70, 80, 90. Now that works, but actually it gives us quite a big gap. So instead, let's try to use a bigger scale for that. Usually your x-axis will fit so that it works quite nicely for you. So let's try making it a bigger gap. So let's make that 50 and then 60 here, 70, 80 and 90. And we can see that works. So if you're doing this in an exam situation, I recommend you write it in pencil initially, or at least count the boxes, and then try and see what you can make it as big as possible. So now we can see each one of those is worth 1. Now going up, we can use the same thing as before, but we can go 1. Now every box worth 0.1, 2, 3, 4, and 5. Our biggest value being 4.6, so that's going to work nicely for us. So we can finish this now by drawing our histogram. So it goes up to 0.75, so all the way up to 0.75, and it goes as far as 70, so it comes across quite a bit. So we're going to come all the way across to 70, and then we're going to come down. Again, using a ruler, you'll be much more accurate than I am. Come all the way up to 4.6. So this is going to be one of our tallest bars. And that's going to 75. Coming across. Then coming down. Then our next one, 75 to 80, goes up to 3.4. So again, there's 3.4, 75 to 80. Coming all the way down to the bottom. And then finally 80 to 90 goes up to 0.3, so 0.1, 0.2, 0.3, across and down, and there's a histogram drawn. Now this one has a follow-up question for us. It says, to qualify in the UK Championships, an athlete must throw the javelin at least 78 meters. Estimate the number of throws that qualify. So what we want to do is we want to go 78 here on our bottom axis. Sorry, we should have labeled this, that's distance. And then this one over here is our frequency density. Okay, so it's always good to label your axes. So if we go to 78, that's here. And again, using your ruler, you can draw this much straighter. But essentially what we're doing is we're thinking about this line here, and we're changing the size of this box. Now we know that this last box represents 3 people. We already know that. Now in a histogram, the important thing to remember is that the area of the box represents the frequency. So that's for histograms. So we're going to figure out the area of this box. Well, the width of it is 2, and then the height of it, if we look, we know that's 3.4. 2 times 3.4 means there's 6.8 people in that area. Okay, now 6.8 obviously, or sorry, 6.8 throws. We can't use 6.8. We can just go, well, 6.8 plus 3 would be 9.8. So we're just going to round that, and we're going to say 10 throws. So again, we just alter the size of the box, find the area of the box, and that tells us the number of people in there. So the final diagram we're going to draw is a box plot. Now box plots look very different. We don't usually mix these up with the other two. So what a box plot looks like is it's going to look something like this. Now they're not always going to look symmetrical. One end might be longer than the other, one end might be really short, the line might be in the middle, it might be a little bit to the left or right, but it's going to look something like this. Now on the first bar, that's going to be our lowest value, which we're given in this question. The end of the box represents the lower quartile. That line in the middle, remember middle means median, so that's your median. The line at the end of the box then is the opposite of the one, so instead of lower quartile is your upper quartile. And then the last value is what we call our highest value, so the highest number that we have. Now if we look here, we've got the lowest value, we've got the lower quartile, we've got the median, we've got the upper quartile, but we've got the range. Now the range isn't one of the values we need, and this is a common mistake we make. They just plot these 5 numbers and don't actually read what they mean. The range, remember, means the biggest value minus the smallest value. So if I want to find the highest value, I'm just going to take my lowest value and I'm going to add my range. So I'm going to take 7, I'm going to add 70, and that gives me 77. So I'm going to add on here that my highest value is 77. So let's put it here at the bottom. So the highest value equals 77. Okay, so the range again is just the difference between the lowest and highest value. So if you add the range to the lowest value, you get the highest value. Conversely, if you take the range away from the highest value, you'll get the lowest value. And now we're going to plot each of these. So again, trying to figure out our scale. That's a gap of 20 divided by 10, which means every box is worth 2. So to find 7, well, if we start here on the left hand side, 0, 2, 4, 6, so it's 3.5 boxes in. And we're just going to draw a little line. I like to use this line here as my center line, and then I go 2 boxes up and 2 boxes down. Then plotting 20, I like to go a little bit bigger, so I'm going to go 3 boxes up this time and 3 boxes down, again using that center box. Now notice I'm drawing all my vertical lines first, then 32 for my median, so 30 and 32, so that line will be here. The next one 45, so 42, 44, so again we've got another half box in here, just to be conscious of. Again, using a ruler will be much neater. And then 77 is going to be roughly here. And again, we're back on those lower and higher values, so we're going to go 2 boxes above and below. Now I'm just going to draw my horizontal lines. The middle 3 lines make my box. And then I'm just going to draw these lines in here to join my tails on. And I'm finished. And I just like my tails to be a little bit shorter than the height of my box. And that will be my box plot drawn. Now the final question for today gives us 2 box plots drawn. And it's talking about 2 groups of students complete a puzzle under timed conditions. Their times in seconds are summarized on the box plot. So that's group A and group B. And it asks us to compare the performance of the 2 groups. Now if you're asked to compare the performance, we want to compare the median and the interquartile range. So the median, which we know from before, is that middle value. So it's that line in the middle. So looking at our scale, again, 0 to 10, that's 10 divided by 10, that means every box is worth 1. So that means this one is 21 for the median. So the median is 21. In the second one, the median is 23. So comparing the medians, we would say the following. On average, group A, now what I like to do is I say group A, and then I'm going to put their value in there, so 21, because what they'll often ask you to do is make sure you've read it. So by putting it in there, it makes it really clear, and it's a nice concise way to write this. So on average, group A took less time You can then write to complete the puzzle if you wish, but took less time is enough than group B. And again, we're going to put group B's median in there. Now, we're not saying whether that's better or worse. We're just saying on average they took less time. Try and avoid using the words better or worse because you might get the context mixed up. In this case, 21 is better because it's time, so the less time it takes, the better. Now, the second thing we want to look at is the interquartile range. Now, for the interquartile range, we're talking about the length of the box, or the difference between the upper and lower quartile. So in this case, the lower quartile, well, if we look at our scale, that's going to give us 13. And in this case, the upper quartile is 29. On the bottom one, the lower quartile is 10, and the upper quartile is 26. So for group A, the interquartile range is 29 minus 13, which is 16. And in the second group, the interquartile range is 26 minus 10, which is also 16. So they've got the same interquartile range. So then we would say, for interquartile range, I'll write it over here on the left, we would say group A, and then we can put 16 in brackets, and group B, and group B 16 scored equally, and the key word here for interquartile range is consistent. So if you're asked to compare consistency, so equally consistent, if you're asked to compare consistency, you want the smaller interquartile range. You're comparing the interquartile range. So that's the key thing to remember here about consistency. So more consistent is equal to smaller interquartile range. Obviously they were the same here, so we say they're equally consistent. Thanks for watching this video. As always, I hope you found it useful, and I hope it was able to help you get to the answers you needed. Again, hopefully I'll see you tomorrow for the next video.